So the first one, A plus quantity, 3 minus B and quantity. And is that equivalent to quantity A plus 3 and quantity minus B?
What is B?
Pardon?
What does quantity mean?
What does equivalent mean?
Equivalent.
Equivalent means
No, you say equivalent.
equivalent.
That's not what you said.
Equivalent?
Yeah.
I said equivalent?
That's what I heard.
Oh, well, I meant equivalent.
Oh.
Equivalent means are they going to give the same result or answer? Okay. So what do we think for this first one? Where's my equivalent people? Raise them high. Come on. Raise them high. 2? 2 people. Where are my non-equivalents? Ooh, there's a lot. Okay. So, gosh, I should know this. Oh, that's the wrong class. Starts with a D. Damari. Damari and Abel, you guys said they're equivalent. Can you prove it?
I don't know if this is the right way or not, but what I do is like I substitute it on A and B for like
Okay.
and like I substituted A for 1 and then B for 2, so it's the same for both things.
Ah.
And then both of them are the answer 2, so that's what's the equivalent.
Okay, so one way to do this is to substitute actual numbers in. I will tell you most of the time, do not use the number 1 or 0. You know, try to use another number. So you said you used 1 and 2. A is 1. Okay, so let's see if that works out. So if A is 1, we get A plus quantity 3 minus 2. Is that going to be the same as 1 plus 3 minus 2? Here you do parentheses first. 1 plus 1 is 2. 1 plus 3 is 4, and 4 minus 2 is 2. Well, that works out to be the same.
How is 1 plus 3 is 2?
1 plus 3 is 4, and then 4 minus 2 gives 2 as the final answer. Okay, so that definitely is a good way to check. Okay. Okay, now those of you that said not equivalent, what were you thinking? Substitute the letters in the parentheses. What do you mean?
Like where you're substituting, substitute B minus B, and then B substitute A plus 3. But
I don't know that we can substitute what's in parentheses for each other. But let me ask you this. According to order of operations, you're supposed to do what's in parentheses first, correct? So when you do 3 minus B, can you actually simplify that? 3 minus B? No, you can't. So essentially, the parentheses kind of go away, all right? And what about for A plus 3? Can you simplify that? No, you can't. So essentially, it becomes A plus 3 minus B, and is that equivalent to A plus 3 minus B? They are pretty much the same thing. Whether you do it by substituting numbers in, or you try to do it by simplifying, but you can't really simplify here. So they do actually result to be the same. So nice job. Very good. Any questions about that one? What if you really wanted to make sure? So yes, it came out to be 2 equals 2. What else might you do here?
Use different numbers.
Absolutely. Use a second set, because sometimes when you use one set of numbers, it might work just for those numbers. You might want to try a second set. Okay? Didn't have to this time, but you might want to next time. All right, let's take a look at the second one. 2 plus k divided by 5 and 10 plus k. Equivalent or not equivalent? Do I have anyone that feels strongly about this one? Okay, you answer a lot of time. Let's share the wealth here. Anybody else feel strongly that it's equivalent or not equivalent? Isaiah, what do you think?
Equivalent.
You think equivalent, okay? Why?
Because how I would say, so 2 plus k and 5
Uh-huh.
fits here. So instead of adding k, I multiply 2 times 5.
Uh-huh.
That gives me 10, and I left the k. So
Okay, what about this k? I see what you said. You said you took 2 and multiplied it by 5, right? And why did you do that? Do you know?
I guess I was thinking of even numbers.
Okay. Okay, because, and you knew this was 10, so maybe you were trying to reach 10. Now this 2 is what as a fraction? It's a whole number, but I can say 2 over 1. So if I want to make an equivalent fraction, you're right, Isaiah. You do want to take it times 5 over 5, and that gives you 10/5. But now, because they have the same denominator, we can add these together and get 10 plus k all over 5. So you were partially right here.
You can also divide 10 to 5 and you get 2.
That is true. Yes. Yes. And so if you are comparing 10 plus k divided by 5 to 10 plus k, are those two going to be equivalent then? No. Because this is just the amount in the numerator, and that's equal to this as a whole amount, but if you divide it by 5, this is going to be much smaller. So the answer here is not equivalent, okay? So if you have something as a fraction, try to change your other whole number to that same fraction, same denominator, okay?
What if you multiply and then add? Like 5 and then add 2k.
I don't think that's going to work, okay? So for the first one, we have the first one was equivalent. The second one is not equivalent. Let's take a look at the third one. I love doing this one. So you have quantity A minus B, that quantity squared. Is that equivalent to A squared minus B squared? Is that equivalent to A squared minus B squared? A minus B, that quantity squared, is that equivalent? Stay with me, okay? Is that equivalent? All right, so let's see. Equivalent and not equivalent. Anybody have any ways to prove it? Distribute? What are we distributing here?
Power 2.
Huh?
Power 2.
No, because it doesn't say 2 times.
No, I meant like when you're substituting not like substituting for that, wouldn't that be A squared?
I don't know. What does quantity A minus B, that n quantity squared, mean? If I were to write it out, what does that mean? How could I rewrite it? In other words, if I have 5 squared, what does the answer is what? 25. And what does that mean? How did we get 25? 5 times 5, right? So we took our base and we multiplied it by itself 2 times, basically. So if I say quantity A minus B, what's my base here? What's my base? A minus B, and if I square that and write it out, what would that be? What would it mean? Yes, that's what I'm looking for. It would be A minus B times A minus B, right? Now, could you simplify this, Javion? Could you simplify this using double distributive? Because this you can distribute. You are taking this A and multiplying it by the first term, and taking the same A, multiply it by the second term, and then you take the negative B and multiply that by the first term, and negative B times negative B. Have you done that before? Or what's it called? Oh my gosh, total FOIL method, which they always tell us not to tell you, and I'm like, why? FOIL method. So what is A times A? A squared. And what's A times negative B? Negative AB, right? And then if you look at the minus B and try to multiply that, negative B times A is going to be another negative AB, and negative B times negative B is? Negative times negative is positive. Okay, so I can combine these like terms. I have A squared minus 2AB plus B squared. Is that going to be the same as A squared minus B squared? No, because here you are adding them together. Yes, you're subtracting 2AB, but that is not the same.
Wait, what happens if you just add squared into parentheses?
What happened to what?
What if we just add the 2 squared to the parentheses?
What if we just add 2 squared? 2 squared.
Not 2 squared, but squared to the parentheses.
Don't think that would work. Maybe you guys are thinking of the shortcut. There is a shortcut, which is if you have A minus B squared, you take the first term and you square it, which is A squared. You take 2 times the first times the second, which is minus 2AB, and then you take the last term and square that, which is B squared. But it is not just A squared minus B squared. So that is not equivalent. And what else could I do to help try to figure this out? Substitute values in. Did anybody substitute values in?
How do you do that?
How do you do that? Well, you pick a value for A, let's say 5. You pick a value for B, and you say, is 5 minus 3, that quantity squared, is that the same as 5 squared minus 3 squared? No, because 5 minus 3 is 2, 2 squared is 4. Is that the same as 25 minus 9, which is 16? No. So not equivalent. All right? Okay.
Well, it would be with 4 squared.
Would be what?
It would be if it was 4 squared equals 16.
But it's not. So it's not. All right, last one. 3 times quantity z plus w. Is that equivalent to 3z plus 3w? I get a lot of head nods on this one. Equivalent or not equivalent? Why does this work? It is equivalent. Yes, Noelia? Yeah, it is the distributive property. You have to distribute the 3 with both of those. So you get 3 times z plus 3 times w, and that is equal to 3z plus 3w because of distributive property. Beautiful. Any questions about those first 4 problems? And like I said, I think that homework number 2 is the rest of those problems on that page. Some of them, yes, are a little bit more difficult, but if you want to show some work, this is where you can do it, you know, because it's already there for you. All right, so let's turn to page 67, and I'm going to be looking for some volunteers here.
Volunteers?
Yes, volunteers.
Wait.
So it says on page 67, in the following figure, and we're looking at this figure of the orange line with the orange dots on it. That's the figure we're looking at. Can you show an interval of length that is x plus 1? Can you show an interval of length which is x plus 1? Also, please note below they are giving you some values of length. So this is 1, that's x, x, 1, x, and 1.
Is
So,
this one the addition?
This first one is addition,
No,
x plus 1.
I meant the yellow line, the circle dot.
Well, that's for you to decide. They're saying this from here to here is a length of 1. This from here to here is a length of x. From here to here is x, from here to here is 1. So can you show on that orange line, that's orange up here, I realize it's gray on your paper, where can you show x plus 1? Flip the page. In other words, would it go from here to here? Would you say this is x plus 1? Hopefully not. Yeah, that's not x plus 1. So first of all, show me some place on that line that is x plus 1. Okay. Do I have a volunteer that would like to come to the board and show me x plus 1? You are so good about volunteering. We've got to share the wealth, though. We need to let others participate.
Well, they don't wanna.
Like people I know, I never know their name because they never say much. Amani, can you come up and show me x plus 1? No? Want to try? All right. Who else haven't I talked to? Stacy, can you come up and show me? No. You guys, you have to try. We're supportive here. We aren't going to boo you out or anything, right? Right, guys? We're not going to do that, right? You better not. Okay. Diana. No, I don't know. Don't ask me. Chris. Janetta. Thank you. Thank you. It goes so much more smoothly when people volunteer or if they accept the challenge. I know you would have. Show me x plus 1. Oh, I got to put the little. You know, I don't even think I have a pen over here. You just use your finger. People don't like that. I found out. They want that pen. Do you want the pen? Oh my gosh. Okay.
I don't. It doesn't matter if I
I just rather use my finger.
Did you charge her or something?
Here we go. The magical pen. Pick your color, red, blue, green. Chris, you awake?
I'm up.
Okay.
Um,
All right.
What?
So from here, you're saying from here to here. That is x plus 1. Okay, thank you. What do you guys think about that?
maybe it has to be on the dot.
Maybe it has to be on the dot.
Because the dot little is like separating the values.
Mm. So maybe the dots are separating the different things. What do you think, Janetta? You happy with it? With what you have? Oh, what she said. Okay, so what if I did, no, that's not.
But they got different colors.
Yep, we got different colors. What if I did something like this? And said that is x plus 1. That's a little over the top, isn't it?
Yeah.
Is that right?
Yeah.
No? Why is that x plus 1? Or why isn't it x plus 1?
It is. What do you mean?
Well, some people are shaking their head no. I just want to make sure.
It's just going over one x and then the 1.
Okay, because from here to here, whoops. From here to here,
X
this is x,
And the other's 1.
and from here to
is
here
1.
is 1. So I think that should be x plus 1.
Mm-hmm.
Okay.
There could be a lot of ways to put x plus 1.
A lot of ways.
Like, you can also go from like the right or the left to put x plus 1.
Oh, let's see. So say more about that. Like where?
So like to the end of the 1,
Mm-hmm.
all the way to the right.
Oh, like this.
Yes.
So this is x plus 1.
Yes.
What do you guys think about that? Is she right? Chris, is she right? What is that? Is that a yes or a no? Come on, people, wake up, smell the coffee. Is there any more x plus 1s? Where?
At the beginning.
Over to the left, yes, right here. Oops.
It just move that.
Over here, x plus 1. Okay. Now I lost it. That's why I should have put it up there.
Yeah.
All right, now, do I have someone, so this is in red, my x plus 1 is in red. Can someone show me 3x plus 1? Where is 3x plus 1 up here?
I think I know.
Anyone? The magic pen? Shemaya? Caitlin? Janetta? Janetta wants to come up and see if she can do this now. Man, I'd be popping up here at the board all I could.
Cute. There's another
So
option.
3x plus 1. Ooh. Ah. What do you guys think of that?
Yeah.
Is she right?
Yes.
Yeah, because there are, here's 1 x, here's a second x, here's a third x, and the 1 in between. So from there to there, that is 3x plus 1. Huh. Imagine that. All right, and for our final trick, can someone show me 3 times x plus 1 n quantity? I don't know, is it?
It is. It is.
Is it?
Yes. Because 1 and 1 and 1, that would be 3. And then x plus 1, it was 2.
So does everybody want to show that?
Me.
You want to show it?
Yes.
Okay. Oh. Cut it up high, yes. Too many. There. Is she right? Yes. There are 3 x plus 1s. Here's the first one, right here. Here's the second one, right here. And here's the third one, right here. So we have shown each one of these separately. So the questions here says, what do your answers tell you about whether 3x plus 1 and 3 times x plus 1 are equivalent? What does this show you?
There are.
They are or they are not?
They are.
They're not? Or they are?
Oh, wait, no, no.
Well, the green is the entire thing. 3x plus 1
They're not. Never mind.
is in blue. So on your paper, why are they not equivalent? Because they are different lengths. Okay? Different lengths. So write something to that effect on your paper.
But I mean, wouldn't the red one and the blue one be equal? Because like it kind of like takes the whole thing.
Would the red and the blue be equal? Here's
No,
the red.
No, I said red and green.
The red is here. And the green is here. The red is just x plus 1. And we just showed 3 different ways to do it. But yes, taking 3 of them times x plus 1, yes, because it's 1, 2, 3. So 3 of these is the same as 3 times x plus 1. But 3x plus 1 in blue is not the same as 3 times x plus 1. I know you know how to distribute, some of you. I was looking at your expression things the other day. Some of you do not recall how to distribute exactly. But this proves it lengthwise that they are not the same. Okay? All right. Go to the dot page on the next page. We have just enough time. Just enough time. It says at the top,
Draw a rectangle.
yes, I want you to draw a rectangle on that page that has all the corners on the dots. So use up half the page. Draw as big or small or however you want to draw. I need you to draw a rectangle that has all the corners on the dots. Quickly, quickly.
Right.
Draw a rectangle. You know what a rectangle is. You don't know what a rectangle is.
I don't know.
What is a rectangle, guys? How can we explain a rectangle?
It's
How many sides does it have?
4 sides.
4 sides. What can we say about the sides?
Double.
2 long sides that are exactly the same length and they're opposite each other, and 2 short sides that are exactly the same length. And what do we say about the corners? They must all be
Connected.
right angles.
Right angles.
Okay, that's a rectangle. Okay, so I need very quickly a volunteer. Come up and show me your rectangle. Quick, quick, quick. Isaiah, come on up. Show me your rectangle. Oh, wait. Wrong. I guess I could use that too, but. Okay, very good. What do you guys think? Is that a rectangle, all corners on the dots? Is that the only rectangle you could have drawn?
No.
Can I have at least one more, very quickly? Girl, right here. Anybody? No. Chris? Janetta? Janetta's like, I'll go up. All right, while she's doing this, we'll see what she comes up with. Can you draw a rectangle that has at least one corner not on the dots. All right, she finished hers up. What do you think? Does that work?
Yeah.
Yes.
As long as
Are these the only two we can use?
No.
No.
Wait.
Can anyone at all, draw a rectangle that has at least one corner that is not on a dot?
What?
You heard me.
What do you mean? Wait.
Can you draw a rectangle that is not, has at least one corner that is not on a dot? Anyone?
Has to be at least one.
At least one. Anyone?
Wait.
How many seconds do I have?
Wait, what do you mean
So
by
already.
at least one?
Should be
Like,
like 90 minutes.
At least, okay. Good. Yes, Diana. Let's hear it for Diana. Got someone who volunteered. At least one. Could be more than one. Has to have at least one.
Oh my bad. I use this head, right?
Yeah.
Would that count?
I don't know. Let's ask them. What do you guys think? Is that a rectangle?
Yes.
Is at least one of the corners not on a dot?
Yes. Two.
Yes. So is she right?
Yes.
Yes. Good job. So why do we do this?
I don't know. But I got a question.
Yeah.
For the first one, is it possible to draw a slant or rectangle?
Is it possible to do a slant or a rectangle? Yes. Why did we do this? Okay, that's bad. There we go. Why did we do this? Just because you have the dots on the page doesn't mean you always have to follow that direction. Sometimes you need to think outside the box. You need to do that a lot more in this class, okay? You need to be actively engaged. You need to be asking questions, and you need to try the homework, okay? So continue to think outside the box. Do those three things, and you'll be fine with this class. You know what I did again? I thought this class ended at 32. Again, it's 36. I should have had more people go up here. But yes, don't always think, oh, dot, it has to be on a dot. It doesn't have to. That's not the only one. Okay? You could have gone like this. You know? Something like that.
That's a square.
Is it?
Is
It's
it
about 3.5 by 3.5.
It did not look.
Is it a rectangle?
It did not look. Like
Is a square a rectangle?
No, but yes it is.
Every square is a rectangle. But very good. Very good. Who's your geometry teacher? Who's Nick? Brian? Who's Nick? Tomczewski?
I had
I have
geometry
two of them. I have Mr. Jesky and Miss.
Jeski?
I got two
Okay.
different kind of. So, never mind.
All right. So think outside the box. Keep thinking outside the box. Keep working on the homework. I do have to get the homework 1 graded. So if you haven't done it yet, do it today because I'm going to put the grade in today. So if you haven't done it and you don't do it before I get to it tonight, it will be a 0. And all we have in there is 1 homework assignment so far. Okay? So, whoops. It doesn't like this pen. Keep working on the homework assignments. And I need to remember that you guys are not done at 32. You're like, oh, it's okay. You know. All right, we'll see you back tomorrow. Yes.
Two.
Homework 2 you can start on. I am going to grade homework 1.
Oh, I
It's-
finished that one, yeah.
Oh, okay. It's technically not due until the end of the chapter, like that's the final date.
When are we grading 2?
This one,
Oh, yeah.
probably not till early next week. But you can do it. You can try it. Okay?